Welcome to the first installment of Stratasys in Manufacturing. This is a mini-series that describes how 3D printing can complement traditional manufacturing processes. My name is Drew Davis, and I'm a manufacturing application engineer here at GoEngineer in Northern California. For this installment, I'm going to be focusing on the machining process. I'm going to describe some ways that 3D printed parts could be used in your traditional machine shop. So what does a machine shop look like? Usually you'll find a mix of CNC lathes and mills of various sizes, Swiss machines, screw machines, or multi-spindle machining centers. You might find manual lathes and mills for doing post-op work. There will be workbenches at every station, and there might even be a worker for each machine. You can see some examples in these pictures. So where does 3D printing fit in? Some applications that I've come up with include soft jaws, guards and shrouds, and it's important that these not be critical safety features. Tool holders and other organizational devices for production parts too, not just tools. Small part sieves and damage-free work catching. And additive manufacturing to machining is a whole nother realm that we'll get into in other slides. And by that I'm referring to metal 3D printing. And finally, end-of-arm tooling. The first example for additive manufacturing for machining that I'm going to mention is printed soft jaws. When you typically think of soft jaws, you might think of a softer material like lead, plastic, or wood that is put over the clamping areas of a vise to keep from damaging the objects that are being clamped in that vise. With 3D printed soft jaws, we can customize these features on the soft jaws to hold specific work in a specific way, and again, without damaging the work. I also found an image of a chuck. You can see that on the left. This would likely be used to hold parts or bar stock without marring the surface. I can see this being on a B-side spindle, for instance, used to pick a nearly finished part from an A-side spindle to do work on the back side of a part. Now, if you've ever been in a busy machine shop, you'll notice that it gets difficult to be efficient when tools become disorganized. If you were to print a tray with spaces for specific tools, you'd be inclined to put that tool back in that space. And this is a great opportunity for 3D printing because a lot of shops could use this for 5S initiatives. Now, what is 5S? This is a whole nother topic, but it's a lean initiative from Japan that translates to sort, straighten, shine, standardize, and sustain. And the purpose of 5S is to eliminate waste and organize equipment and processes to achieve maximum efficiency. It has the added benefit of giving the shop floor a nice and tidy appearance, which improves morale, but that's also for another presentation. Ultimately, the point is, organizational tools can be made to be completely customized so tools won't walk off and they've got a place to be and they're well organized. Now, in a related application, why not protect the parts you're producing with a container, box insert, or tray that is customized for the parts that you are making? It can insulate them from being damaged. Now, these pictures illustrate some of the current ways parts are being stored and some of the ways they could be stored. If your parts require a high external finish, why would you then stack another part on top of it or next to it? You put time and money into achieving that surface finish and making a good part only to damage it in transit to assembly or finishing. Having an organizing device could prevent scrap production and increase your yield. One of the other benefits of having customized parts holding devices is the ability to keep more accurate counts. You can keep better track of production in real time by being able to quickly verify counts at the machines because the parts are stacked or stored in an organized fashion. And this could even be used to reinforce some of the technology that's out there already that keeps counts automatically. For certain situations, you could print guards and shrouds. I mentioned my little disclaimer in the second slide. The guard must not be a critical guard. You wouldn't replace the door on your mill or lathe with a 3D printed door, for instance. But to protect a worker from a manual lathe spindle or protect an e-stop from getting bumped, those are good uses. Those are good applications for 3D printing. Another example might be keeping belts and chains protected. I think this could be a very good application, particularly if you need custom shapes. If you have a 3D printer in your shop already, why not print shrouds and increase the safety of your shop? End-of-arm tooling is an application that's already been investigated and proven. It hasn't been explored for machining purposes really though, because the parts are generally larger and heavier. But if the parts you're producing are candidates, you could use a vacuum system to pull and place parts. Otherwise, you could print the jaws and actuators for clamping. As you can see in the top left picture, that's a robot loading a blank into a spindle. You can utilize printed end-of-arm tooling to more carefully and accurately pick and place blanks or parts with robots and get one step closer to achieving that lights-out shop. One machine shop that I used to work at produced small parts on our Swiss machines. The parts were no larger than a centimeter square by a millimeter deep, and these were difficult parts when you consider you have to catch them and separate them from the chips in the cutting oil. And due to their size, of course, we were constantly losing them, and our yield on the job was pretty terrible. We started using devices like the ones shown in the two center pictures to catch parts, and though it was still a very manual process to separate the parts, we were able to increase our yield. We weren't throwing parts out with the chips. It would have been nice, however, to print a container with a screen at the bottom to catch parts and let the chips fall through. Parts catching and filtering, I think, is a great application for FDM, fused deposition modeling. With the FDM process, we have the ability to define the air gap between the rasters, or the zigzag filling structures on the inside of parts. And with Stratasys Insight software, we can remove solid bottom and top layers, so we're left with containers with screen-like bottoms of different shapes and sizes. A lot of lathes have mechanical parts catchers for larger parts. These are devices that move into position under the spindle and wait for the part to be ejected, and then convey it to a tray in the door so the operator can remove it from the machine without having to open the door. This type of device is used to increase the efficiency of the machine. The problem is, a lot of them are made of metal and introduce the opportunity for damage. One could print a liner that would allow cutting oil or coolant to pass through and still catch the part without damaging it because it would be a softer material. Again, these are great applications for FDM. For jigs and fixtures, 3D printing has it in the bag. How many times have you had to wait on the quality department to confirm the first article? Let's think for a moment about what the average quality inspector has to do to complete a first article. They have to get one of the parts to inspect off the machine. Then they build stack-ups on the CMM to hold the part the same way every time. And then they train the CMM to check the important features of the part. Now what if they could print the part and a fixture to hold it in place? They could then complete their process before the first chip was cut. We've seen significant savings in time and money in the quality assurance arena at most companies. And interestingly enough, the more complex the geometry of the part you need to hold, the more valuable 3D printing a jig or fixture for that part becomes. There's an excellent case study from Oruk Vacuums, where they had to wait until the first molded parts came out to confirm the first article from a die-cast tool. And because they had to build a complicated stack-up to hold the organic shape of the part, and then set their program for the CMM, the wait was sometimes weeks. Well, someone came up with the brilliant idea to reverse the geometry from the part and build a fixture to hold the parts accurately and repeatedly. Then, they printed a surrogate part and used it to program the CMM. So when the first article came off the tooling, they had a fixture set up on the CMM and a program written for it. 3 hours later, they were through the first article inspection and on to production. And when I want to reinforce this, the more organic the shape, the better fit 3D printing is. An interesting, simple application for 3D printed parts is the segmented cooling lines. In fact, the most common component of these tubes is already a free download on a site called Thingiverse. A site where random users upload STL files and anybody with an account can download them for free. You could print replacement cooling lines tonight. But as I have mentioned already, the more complex the geometry, the more advantageous it is to 3D print. So why not print job-specific coolant line nozzles that are customized to spray coolant exactly how you need it for the part you're machining? One of the most significant areas of advancement in 3D printing has been in the materials arena. There are now multiple ways to print with metals. These metal parts come off the machine with a matte finish, as you can see in the pictures, and usually need to be machined in a secondary process in order to clean them up. You're probably noticing the mounting surfaces on the parts shown on the screen. Those surfaces were machined to a high surface finish in order to seal appropriately. But once that's done, they're fully functional metal parts. In fact, that center picture is a filter that was printed in one piece by Oak Ridge National Laboratory. Those fine filter features are printed in place. There's no assembly required. Finally, if you don't have a machine shop yet, you could use your 3D printer to print your first lathe. So this was a partial list of the ways a machine shop could utilize 3D printing. I say partial because one of the most interesting things about 3D printers is the fact that you can always find new ways to use 3D printed parts. But why bother changing from the process that has worked for so long? Cost savings in the form of slimming down on-hand inventory, say of jigs and fixtures, and eliminating damage to finished parts. Rather than keeping shelves and shelves of expensive jigs and fixtures, you could keep a digital inventory and only print them when you need them. Time savings. Remember the jigs and fixtures slide? Oric was able to save weeks. And also, keeping your shop clean. It can boost efficiency, but more importantly, it can boost morale. My email is down on the bottom left corner of this slide. Feel free to email me. This was Drew Davis. Thank you very much.